Thank you all for joining us. I'm Jen Perron, a Climate Policy Fellow with the California-China Climate Institute, and we're delighted to welcome you here today to discuss opportunities to advance energy efficiency and air quality co-benefits for California, China, and beyond. Today, we are releasing new research on this topic, which is now available on our website, ccci.berkeley.edu. We welcome you to take a look. Before we get started with today's program, I'd like to note a few quick housekeeping remarks. Today's program will last approximately 1 hour. The event is being simultaneously translated. At the bottom of your screen, click on the interpretation globe icon and choose the audio channel you wish to hear. To hear the interpreted language only, we recommend that you choose the mute original audio option. This will mute the sound of the original audio if it is speaking in a different language than the one other than your own. During the interactive portion of our discussion, if you have a question, we welcome you to enter it in the audience Q&A panel. We will attempt to answer as many questions as we can today live. Without further ado, I'd like to introduce our first speaker, who will be talking about energy efficiency and air quality co-benefits within the California context. Dr. Robert Weisenmiller is a research affiliate with the California-China Climate Institute. Dr. Weisenmiller is one of the world's leading voices on energy issues. For more than 9 years, he's served at the California Energy Commission under Republican and Democratic administrations. First appointed by California Governor Schwarzenegger in 2010 as a commissioner, he was appointed as chair in 2011 by then Governor Edmund G. Brown, who currently chairs our institute. Dr. Weisenmiller has provided expert witness testimony to more than 100 state and federal public regulatory agency and court proceedings, and has authored numerous publications on electricity and natural gas markets. Bob, I'll turn it over to you for your remarks.
Thank you. Good morning and good evening. I appreciate the opportunity to get together and talk about energy efficiency, although this is a little bit more energy efficiency 2.0. Let's start with the first slide. And I wanted to really call out my colleagues who've worked with me on the paper. It's obviously not just my activity, but certainly have had a very strong support group, and certainly appreciate everyone's work on pulling this together. Let's go to the next slide. Talking about co-benefits, and particularly this looks at both co-benefits of energy efficiency and renewables. Obviously, our paper focused much more on energy efficiency. So as we go around the chart here, I'll try to just focus on the energy efficiency part. As it indicates with the first box over on the left, what you can do with energy efficiency is reduce electricity demand. And once you reduce electricity demand, going over to the next middle boxes, you reduce emissions. And reduced emissions improves public health. It also enhances the electricity system, since energy efficiency reduces the cost, and it will reduce the risk. And it also boosts the economy because it lowers energy cost. And certainly there are jobs associated with the energy efficiency programs, and this will also increase disposable income. So finally, getting to the bottom line, there are substantial benefits to society. And looking at specifically on the co-benefit side, there are numerous air quality benefits and health benefits, along with the economic. So the concept of co-benefits is very important. Let's go to the next slide. I'm going to first look at the sort of greenhouse gas questions. And California has had very aggressive greenhouse gas goals. The first one for 2020 to reduce to 1990 levels, and that occurred in 2017. So we actually were ahead there. 2030 is obviously a big step, which is getting 40% below 1990. And we're still in progress there. And then finally, 2045 is zero net carbon, which is obviously a very important but very challenging goal. Let's go to the next slide. This is, again, give the basic message of what California has seen so far is that what California has managed to do, and this is 2018, so we're missing some of the COVID effects here. But as you can tell, California has reduced its greenhouse gas emissions, and it's done so with reductions in terms of per capita and per GDP. And at the same time, it's increased GDP. In fact, California, again, before COVID, would be the 5th largest economy in the world. So we've really demonstrated, I think importantly, to China and all the other countries, that it's possible to both grow the economy and to reduce greenhouse gas emissions. Let's go to the next slide. It's important to talk for a second about where California's greenhouse gas emissions come from. And bottom line is we're really dominated by transportation. It's 41% directly in the tailpipe. There's another about 10% that's buried under industrial that goes for producing and refining gasoline, and diesel. So bottom line, transportation is more like 52%. Electricity is 96%. And we're going to talk a lot about buildings, which is another 12%. So again, going to the next slide. California, the ARB has been designated to come up with the scoping plan. And the scoping plan is basically California's plan or what pathways it's going to use for greenhouse gas reduction. It's updated every 5 years. And 208 was the first time where it showed it was feasible to reach the 2020 target. And as I said, we actually beat that. 2014 started looked at progress to date, started looking at short-lived climate pollutants. And then 2017 looked at the 2030 targets. The ARB just started its proceeding to update for the 2022 scoping plan, and it has various aspects it's featuring. One is it has to come up with how to deal with zero net carbon. It obviously has to look at progress to date, and it's got to look more at some of the air quality implications or sort of the code, basically what's happening in some of our environmental justice areas, which, frankly, some of our poor areas are where we have a lot of the emissions. So trying to make sure that we're not concentrating impacts in those areas. Obviously, one of the targets for the scoping plan is to make sure we're not just shifting emissions out of California. And the scoping plan really provides opportunities for subnational or national collaboration. I'll talk about this at the end, but certainly it's on a target which allows coordination with China's 5-year plan updates. Let's go to the next slide. This is the portfolio that came out of 2017. As you can tell, one of the goals is really to double down on building energy efficiency. A lot of different aspects, as you might imagine, on transportation, and certainly trying to reduce the emissions associated with the grid. This had the 60% target. Since then, California has gone to 100%. But as indicated in the slide, almost everything touches on transportation. But again, transportation is over 50% of the greenhouse gas emissions, and I should indicate that it's also over 80% of the criteria pollutants. So if you're trying to deal with greenhouse gas emissions and air quality, you really have to deal with transportation at sort of the top of the pathways. Let's go to the next slide. One of the questions we asked last time was, how much do the local districts really reflect energy efficiency and the co-benefits back into their state implementation plans? Now, California has about 35 air quality control districts. They range from, they regulate stationary sources, while the Air Board does mobile sources. The two that are really have problems in terms of meeting or non-attainment are the South Coast and the Central Valley. The South Coast is certainly the most sophisticated and most challenged of the air districts, and it has a pretty explicit role for energy efficiency in its state implementation plan. This is the last one. Presumably, again, they're getting into the update phase now. Presumably it would be broader, but they're pretty explicit and recognize the importance of the energy efficiency measures. Let's go to the next slide. This slide, what I'm trying to do here is show a couple of things. We're really not talking about renewables per se in the paper, but it's really the elephant in the room. As you can tell, there's been a phenomenal growth in renewables in recent years, and particularly in solar and wind, which are the more intermittent resources. So basically, when you look at California's overall grid mix, that at this point, California's definition of renewables is about 38%. In addition, California does not include large hydro. Large hydro can vary from year to year with hydro conditions, but that's at least another 15%. And in addition, we have about 10% nuclear. So California is about 60% that is non-fossil fueled, and that's 40% is actually split between gas and imports. And the imports out of state could be coal, it could be hydro, but anyway, bottom line is you can see there's been a big growth in the intermittent resources, and that means there's a lot of focus on storage and demand response. So let's go to the next slide. California has had a long history of building standards, and is, since the 70s, frankly. And in the 2019 one, which is the one I was involved in, we basically require photovoltaics to offset basically I was going to say more the baseload expected energy, annual energy, electricity, but they've set very high performance standards for basically the tightness of the building and the level of insulation. 2022, that's in development. There's a draft out now. And again, they really started shifting. I was just talking about energy efficiency 2.0, was to start adjusting our energy efficiency approaches to focus more on greenhouse gas emissions than on simply reducing energy. And one of the things we've done is starting to look much more at moving towards all electric as we go forward. In fact, and at the same time, this series, the 2019 dealt with single family. This will deal with multifamily, which is about half of California's new construction, and also more commercial. So it's really adding in photovoltaics and storage for those non-residential buildings. And for all mixed fuel buildings, it requires it to be electric ready. As we'll talk about at the end, these standards have to be cost effective on a life cycle basis. Generally, the heat pumps aren't quite there yet they need a reduction in their cost to really deal with cost effectiveness. So we'll really need some innovation and scaling. Let's go to the next page. Energy Commission also has been doing appliance standards since the 70s. We've really, obviously China picked up appliance standards too in the 80s. There's a lot of back and forth now. Last time when we adopted computer monitor standards, basically we started with computer standards. We started with the standards the Chinese have adopted. And sort of adopted those to meet California specifics. But again, they must be cost effective over the life cycle. And going to the next slide, and they basically set a minimum standard, but one of the recent legislative actions is to really allow the Energy Commission, or require the Energy Commission, to really start building load flexibility or demand response into its appliance efficiency standards. So that California will require that sort of flexible load, which again ties back to what we need and what certainly China would need as you have more and more intermittent resources on the grid. And so one of the things we really need there is automated, low-cost communications and control technology to allow load shifting. Let's go on to the next slide. We've been talking about basically new construction. New construction in California is at most 150,000 new buildings a year. And like I said, about half single family, half multifamily. 100,000 is not unusual. We have over 10 million existing buildings in the residential sector, and obviously a lot of square feet. Again, if you look at non-residential, an awful lot of more existing buildings than what you see in terms of annual construction. So we're really trying to come up with a benchmarking program and using big data. And so this is over a certain size, and we hope to keep decreasing the size for commercial buildings, and to really have a benchmark that people can use when they're renting or buying space, to really use market forces to try to get more retrofit to occur. Let's go to the next slide. One of the things which we're looking at is what are the air quality benefits of total electrification? So the Energy Commission gave a contract to EPRI to really do a study on that. And it's across the board electrification. I'm not going to claim all of it is cost effective now, but you can see that if we can really electrify everything, that has substantial air quality benefits. And if you go to the next slide, this is part of the results there. This shows the results for the South Coast. Again, the South Coast has obviously been air quality problems since at least the 60s, and really a lot of focus. It's still non-attainment, but this shows quantitatively the benefits that could occur with electrification scenario. And this shows you the basic categories of on-road, off-road, residential, commercial electricity. So again, substantial reductions in benefits. And I think it has to be really a key part of how do we, by 2050, really bring the South Coast into compliance. Let's go to the next slide. A lot of questions about storage. And I think part of the bottom line, as you can see, there's been phenomenal cost decreases, which have really helped there. Let's go to the next slide. One of, I think everyone has probably heard about California's reliability issues last summer. There's been a real push into basically grid scale storage. And this is the Moss Landing plant, which is online now. It's going to be further expanded by 2021. And it'll be further extended following years. But this is now the largest storage power plant in the world. California will add about another 2,500 megawatts, or actually 2,500, including this 400 by August, to try to deal with the reliability issues. So it's really driving, getting lots of experience now what happens as you add more and more storage to the grid, and what are some of the issues there. Let's go to the next slide. How's California developed so much storage? Part of it was that basically Assembly Bill 2015-14, which was actually, there was an earlier bill by Governor Brown, which required the utilities to go out and buy, actually it was 25-14, 1.5 gigawatts of storage by 2024. As you can tell, we're going to surpass that. And part of that was basically putting in place incentives, and on the investment, and with the investment tax credit, that ties into the federal solar tax credit will cover storage systems if they're co-located with solar. So right now, the general approach is to do solar and storage at the same time for behind the meter, and certainly on the other side for utility grade side too. Market mechanisms. One of the reasons why storage is making so much progress in California is our retail rates are relatively high, so storage is relatively cost effective. The other thing is with the fire risk, there's a lot of curtailments now in high fire risk areas. And so obviously people are putting in storage to have more reliable loads. Let's go to the next slide. Transportation, again, is the big picture in California. The strategy there on the ZEV fleet, right now California has, this says 600,000. Current stats are probably more like 700,000 plug-in electric vehicles. That's about half of the electric vehicles in the US. We also have some hydrogen. And Governor Newsom has put in place that basically 100% of in-state sales of all passenger cars will be zero emissions by 2035, and trucks. And as part of that, California is dealing with the chicken and egg of both putting in place charging infrastructure and refueling infrastructure at the same time we're providing strong incentives for the vehicles. Let's go to the next slide. One of the things that's obviously very important as you're trying to both reduce greenhouse gas emissions and clip the cleaner air is looking at trucks, zero emission trucks. And so the ARB adopted a rule in June. You'll hear a lot more about these, and it has goals of 100,000 zero emission, 300,000. Obviously, the technology is not as well baked as for automobiles, but you're going to hear a lot more about that from my colleague from LPNL. Let's go to the final slide. So in terms of conclusions or recommendations, there's a lot in the report to really chew on, but the basic message is there's a lot of opportunities for coordination between the ARB 2022 scoping plan and subsequent ones in the 5-year plan updates. The ARB scoping plan has a significant role for energy efficiency, and certainly I would encourage China to build in significant role for energy efficiency in its 5-year plans dealing with both air quality and greenhouse gas emissions. Those all, obviously, like I said, we're going now into what I call energy efficiency 2.0, where you have to really start rethinking the program some to deal with greenhouse gas emissions, unless we're just savings. It doesn't necessarily do you a lot of good to save energy in periods where you have an oversupply of renewables. Building appliance standards are really important to keep driving towards better new construction, but eventually trying to build in some sort of flexible demand, load management as part of that is really critical. Obviously, storage built in is really important, both behind the meter and utility scale. And we really still have to keep struggling with what to do about retrofitting the large stock of existing buildings. I think we've been working at it now for over 30 or 40 years and still not the progress. There's been progress, but not as much as we'd like. Transportation is really where there's got to be a lot of dialogue. And again, it'd be good to think on a goods movement approach. A lot of goods are manufactured in China, go out to Chinese ports, then come into California's ports, and then go throughout the entire US. So anything we can do to take a systems approach and to really go to zero emission vehicles in China and California will have real benefits for all of us. Certainly port electrification is another way. And at the same time, and certainly zero emission vehicle charging can be an important flexible load, although it's certainly going to add to the systems. So thank you. Looking forward to questions.
Thank you so much, Bob. And next we'll turn to Nina Khanna, who will be speaking more about the transportation sector in China. Nina Zeng Khanna is a Principal Scientific Engineering Associate and co-leader of the Emerging Economies Research Program with the China Energy Group at Lawrence Berkeley National Laboratory. Nina has provided technical assistance to China's appliance efficiency standards and labeling programs, led integrated bottom-up energy systems and environmental modeling, developed low-carbon cities tools, and conducted energy demand and supply analysis. Her recent research focuses on techno-economic and bottom-up modeling and scenario analysis of technologies and policies for accelerating the clean energy transition in China and globally. She is also a contributing author to the Intergovernmental Panel on Climate Change 6th Assessment Reports chapter on mitigation and development pathways in the mid to near term. I'll turn it over to you now, Nina.
Thank you so much, Jen, for the kind introduction. So today, my colleague Hongyo and I are very pleased to be here today to share some results from our recent analysis of how China can advance its energy efficiency while also achieving co-benefits for air quality by really focusing on international experiences and also understanding China's latest trends in the heavy-duty trucking and cement sectors. So for today, I'll begin by discussing our findings on the heavy-duty trucking sector, and then we'll turn it over to my colleague Hongyo to introduce some of our findings for the cement industry. Next slide, please. So we want to begin today's presentation by really looking at how both energy and environmental goals have already been incorporated in China's most recent 5-year plans for socioeconomic and national development. So if we look at the 13th five-year plan, China has actually already incorporated goals to reduce both air pollutants and also CO2 emission intensity, including quantitative goals to reduce SO2 and NOx emissions by 15% from 2016 to 2020, and then also reducing CO2 emission intensity by 18% by 2020. And in the recently released outline for the 14th five-year plan, which will run from 2025, which will run from 2021 to 2025, there's also been a continuation of the quantitative target to reduce CO2 emissions intensity by 18% below the 2020 level, and also qualitative goals that include enhancing the coordinated control of multiple pollutants. So for this project, we really wanted to understand what are some of the air quality co-benefits that can be captured by improving energy efficiency, which at the same time can reduce both greenhouse gases and also improve air quality through reducing criteria air pollutants. And we focus in on two key end-use sectors, which are heavy energy consumers, as well as emitters, which are heavy-duty trucks and cement. Next slide, please. So globally and in China, heavy-duty trucks have been very difficult to decarbonize and at the same time really contribute to significant CO2 emissions and air pollution. And based on our assessment of international experiences, we identified some policy strategies that's actually already been in place to improve energy efficiency and improve air quality, specifically for heavy-duty trucks that have been adopted globally, and also identify some key international best practices. So for heavy-duty trucks specifically, fuel economy and CO2 or greenhouse gas emission standards have only been adopted by 6 countries, and that includes China, Japan, the US, and EU. In addition to regulatory measures, there also have been increased use of ultra-load and zero-emission zones, which are essentially urban zones that put more restrictive requirements for polluting trucks, such as that trucks entering the zone have to meet more stringent emission standards, or they have to pay a fee if they cannot meet those standards. So these zones have been in use in over 250 European cities with documented reductions in black carbon, PM, and NOx concentrations in the case study of London zones that were recently put in place. And they really also provide an incentive for cleaner and newer vehicles, including electric trucks, because cleaner trucks that emit less pollutants do not have to pay fees or face penalties if they enter these low emission zones. In the US, there's also been cases of subnational leadership really driving the setting of zero emission heavy duty truck sales targets. As Bob mentioned, California was the first to set this target back in June, and right after that, 15 other US states signed a voluntary MOU committing to 100% zero emission truck sales by 2050 with an interim target of 30% sales by 2030, and really committed to working together to accelerate the adoption of zero emission heavy duty trucks. And lastly, government-funded demonstration and pilot programs with the support of industry and different stakeholders can really help not only test, but also support the scale up of prototype heavy-duty truck alternative fuel technologies. And this is proven to be something that's been used in Europe, Canada, and many other regions. Next slide, please. So moving from understanding kind of the global context of heavy-duty trucking to China specifically, we also identify some specific challenges in China's market and potential strategies to improving heavy-duty trucks' energy efficiency and air quality. So while China is one of the 6 countries that have introduced fuel economy standards and also have put in place air pollution emission standards, as well as build a policy framework for new energy vehicles, which are battery, electric, and hydrogen fuel cell vehicles, China still really faces some unique challenges to transforming its heavy-duty trucking sector. So currently, the heavy-duty trucking sector has a very decentralized freight operations industry that's really dominated by individual ownership of trucks and delivery services. There's also some market fragmentation in the manufacturing of certain heavy-duty truck types, which makes it much more difficult to invest in R&D and innovation for these newer alternative alternative energy technologies. There are also institutional challenges with transitioning from China's traditional regulatory system to a more market-based policies for supporting new energy vehicle adoption. So based on China's specific conditions and also a techno-economic analysis of the latest alternative fuel technologies, as well as these international best practices, we were able to identify some strategies that can improve energy efficiency and also achieve these air quality co-benefits. And this includes energy efficiency improvements through both heavy-duty truck vehicles and also the operations of these vehicles, and also switching from diesel to more efficient new energy vehicles, which I'll talk more about in the next slide, please. So we identify three main types of opportunities for improving energy efficiency and achieving air quality co-benefits in China's heavy-duty trucking sector. First, we found that there was actually quite a range in the different technical options for improving the energy efficiency of the vehicle itself for these heavy-duty trucks. And they range from advanced engine technologies to lightweighting to improve aerodynamics and tires, and even to driver training to adopt more energy efficient behavior, which can improve the overall vehicle energy efficiency. And the efficiency improvement potential ranges from 2 to 20% for each of these individual options. In addition to improving the efficiency of the vehicle itself, we also identify some specific operational efficiency improvements given the current institutional context for the heavy-duty trucking industry. We found that more centralized and optimized freight operations and logistics can help improve load matching and reduce instances of overloading or underloading. And through optimized routing and things like automated platooning, there are really additional efficiency improvements that can be captured in terms of how these trucks are being used to deliver goods. And so we identified about a 5% reduction potential in the total freight turnover activity by 2030. And lastly, of course, there's the increased adoption of new energy vehicles, such as battery electric and fuel cell heavy-duty trucks. We, through understanding the current sales trends in China and also the current status of the latest technology developments for both battery electric and fuel cell heavy-duty trucks, we found that sales shares of up to 5% could definitely be possible by 2030, reaching as much as nearly 3% share of the entire heavy-duty fleet in China. Next slide, please. And so what we did was basically we used bottom-up modeling of China's heavy-duty trucking fleet, as well as different scenarios to quantify the potential reductions in both NOx and PM 2.5 emissions. So the chart on the left, we can see a range in NOx emission reductions depending on a high and low baseline scenarios of air pollution for heavy-duty trucks. And on the chart on the right, we can see the same results, but for PM 2.5 emissions. So from the chart on the left, we can see, for example, if we look at the red bars, that shows the reduction potential of efficiency and logistics improvements alone. Annual NOx emissions could be reduced by 120 to 240,000 tons per year in 2030. And similarly for PM 2.5 emissions, efficiency and logistics improvements alone can reduce PM 2.5 by 1 to 5,000 tons. If on top of that, we add the incremental new energy vehicle adoption, which is represented by the blue bars, then we can see that there are additional annual reductions of up to 90,000 tons of NOx and 7,000 tons of PM 2.5 by 2030. Basically, combined, these two strategies can reduce as much NOx as Beijing's total annual NOx emissions, and also 4 times PM 2.5 emissions from heavy-duty trucks in the entire Jing-Jin-Ji area. And combined efficiency and NEV adoption can reduce emissions by about 10% more than emission standards alone. So in this next chart, we can see that efficiency and logistics improvements also have very important role in reducing both energy and CO2 emissions. So on the chart on the left, we can see that in terms of energy, Efficiency and logistic improvements can reduce annual energy consumption by about 20% compared to a reference scenario, with slightly greater CO2 reductions as seen on the right. So on a cumulative basis, efficiency and logistics improvement can reduce energy by about 360 million tons of oil equivalent and over 1.1 billion tons of CO2 emissions from 2020 to 2030. And if on top of that, we add the increased adoption of new energy vehicles, then there's additional annual energy reductions of about 1 to 2 million tons of oil equivalent, but much larger annual CO2 reductions of over 70 million tons of CO2 from the period from 2020 to 2030. So we can really see that not only do efficiency, logistics improvement, and NEV adoption reduces NOx and PM 2.5 emissions, but they have additional benefits in reducing CO2 and energy consumption. Next slide, please. So in summary, we found that there was significant potential for reducing energy, particularly in the form of diesel consumption, as well as reducing CO2, NOx, and PM 2.5 emissions from heavy-duty trucking energy efficiency and logistics improvements and NEV adoption. But there's still multiple barriers that currently remain in the Chinese market. Through analysis of international best practices and understanding of China's current market conditions, we identify some possible policy actions for overcoming these barriers in the upcoming 5-year plans. First, we found that introducing and expanding kind of different phases of ultra-low emission zones in large cities could be a way to incentivize the adoption of new energy vehicles and really result in improved air quality. Second, as seen in the US example, encouraging subnational leadership and cooperation in setting ambitious new energy vehicle heavy-duty trucking adoption targets could be another way to drive new energy vehicle trucks adoption in China, as has been done for other climate or energy-related goals at the subnational level. Continuing to support the full implementation of new and more stringent fuel economy and vehicle air pollution emission standards is another way to capture both the energy savings and also the reductions in air pollutant and CO2 emissions. And it's really important to continue to recognize kind of the co-benefit values that these standards can bring as the new standards are being revised and made more stringent. And lastly, supporting innovation and technologies and business models to support logistics improvement and NEV charging is also important to supporting the adoption of these strategies. And this could include examples such as improving supply chain coordination and battery swapping. So with that, I will end my part of the presentation and turn it over to my colleague Hongyo Liu for her remarks on the cement sector.
Thank you, Nina. 谢谢 Nina。今天Thank you, Jen。因为今天考虑到有很多中国的专家和同仁也到会，所以我就用中文给大家接下来做接下来的报告。在我们工业部门考虑到如何提高工业部门的这个空气质量的话，我们主要有2大类途径。第一类途径呢，就是我们大家看到的中间这一竖行，就是采用这个末端处置的这种技术，比如说我们的脱硫技术、脱硝技术。第二类呢，就是采用我们最右边的这一竖行看到的这个采用节能的技术。这2大类技术相比呢，他们都需要有先期的投资，都需要有这个成本的投入。进行安装采用这些技术和设备，但是我们这个末端处置的这种技术呢，因为它不能产生节能量，它也没办法把我们这个降低的这个排放转换为这个效益，所以呢，不能通过这个节能量或者是减排来收回这个技术的成本。但是我们的这个节能技术呢，是可以通过节能量产生节能效益来收回这个技术成本的。同时呢，我们的这个末端处置技术，比如说我们的湿法脱硫技术，是会增加我们的电耗的，而我们的节能技术，它会节约我们的这个用电，节约我们的燃料消耗，是会带来整体的这个能源的消耗的一个下降。 同时呢，这2类技术相比，虽然2类都可以降低主要污染物、二氧化硫、氮氧化物的这样的排放，但是呢，我们的末端处置技术，至少目前市面上可以获得的这种末端处置技术，没办法直接降低二氧化碳的排放，温室气体、二氧化碳的排放。但是我们的节能技术通过降低我们的化石燃料的消耗，所以呢，我们也可以降低它的二氧化碳的排放。因此呢，在末端技术这个领域呢，因为它现在没办法通过节能量或者是减排量来产生这个节能的这个效益、减排的效益，难以收回成本，直接收回成本，而且需要增加电耗，所以呢，对政府来说需要更多的监督和监测，来确保这些终端的这些减排措施得到真正的实施和应用。而我们的节能措施呢，因为它可以产生节能效益，所以呢，企业往往有比较高的积极性，一旦投入以后，确保这个技术得到使用。我们在今天的这个报告当中呢，我们的工业领域，我们主要针对的是水泥行业。大家知道，中国是我们全球的水泥的龙头行业，占全球的这个水泥产量的56%。因此呢，在这个水泥行业当中，我们考虑了一系列的节能技术，在我们报告当中包括了39项节能技术。今天呢，我们也把这个节能技术呢分成2大类。第一大类呢是能够节约燃料消耗的这种节能技术，通过节约燃料的消耗，能够直接减少二氧化硫和氮氧化物的排放。比如说，包括的技术有采用可替代燃料，优化我们熟料避冷机，采用预分解窑进行能量管理和过程控制，优化我们的燃烧系统，生产复合水泥等节约燃料的技术。第二大类技术呢，包括这个节电的技术。这些技术呢，可以间接的减少二氧化硫和氮氧化物的排放，通过节电而就减少了因为生产电而需要消耗的一些燃料。这一类技术呢，比如说有力膜、滚膜，还有低温余热发电等技术。在我们的报告当中，我们需要考虑的、评估的就是采用这些节能技术能给我们水泥行业还能够带来多少节能和减排的这个潜力。因此呢，我们建立了2个情景。第一个情景呢，我们把它称作可能的减排潜力情景，也就是说，在现在的14.5期间，以及在未来的15.5期间，我们假设这些节能技术能够进一步的得到推广，但是推广的速度增加的比例比较慢。第二个情景呢，我们称作最大的减排潜力情景，也就是说，我们假设在14.5期间以及未来的15.5期间，这些节能技术能够以最大的速度、最快的能够得到最大程度上的推广。我们看到在我们13.5期间，我国的水泥行业实现的这个二氧化硫的这个减排量，在13.5期间是达到15万吨左右这样的一个二氧化硫的减排量。这是采用了施法脱硫的末端处置的技术，也采用了节能技术共同实现的这样的一个节能量。但是我们看到，如果我们可以最大程度的采用节能技术，我们还可以在14.5期间实现很大的二氧化硫的减排量，可以达到13.5期间实现的二氧化硫减排量的2倍。也就是说，在我们所有的这个水泥的企业当中，有2800家左右的水泥企业厂，都能够最大程度的采用所有的可行的这些已经商用的这些节能技术，包括比如说生产复合水泥，采用替代燃料优化熟料避冷机降低我们这个回转窑炉壁的热损失进行能量管理过程控制等等一系列技术。在氮氧化物的减排量方面，我们看到在13.5期间，我们水泥行业实现的这个氮氧化物的减排量在110万吨这样的一个规模。 但是我们发现，如果我们可以最大程度的采用节能技术，在我们的最大减排潜力情形当中，我们水泥行业还可以在“十四五”期间继续实现同等规模的这样的一个氮氧化物的减排量。也就是说，我们“十三五”已经做得很好了，做得不错。但是呢，我们发现通过提高我们水泥行业的能源效率，我们还是可以达到同样的规模的这样的一个降低空气污染物的这样的减排量。同时，与此同时，通过采用这些节能措施、节能技术，我们还可以实现减排量。如果我们能够最大程度的推广和采用这些节能措施，我们在“十四五”期间能够实现4500万吨标煤的这样的一个节能量。而把这些节能量再转化为二氧化碳的减排量的话，我们发现我们能在“十四五”期间实现的二氧化碳的这个减排量是“十三五”期间实现的2倍。如果我们可以最大程度的采用这样的节能措施，也就是说，我们“十三五”取得了很好的成绩。但是呢，我们不能够就在功劳簿上睡大觉了。也就是说，我们还应该继续保持、继续的实现我们这些节能的潜力，继续的推广我们的节能措施。我们看到目前呢，我国的水泥行业呢，面临着各项的指标和各种压力，不光是要降低主要污染物的排放，还需要进一步降低能源强度，淘汰落后产能，提高产能的利用率，采用先进的技术，采用协同处理，处置污泥或者城市垃圾，并且呢，我们还要支持和实现习近平主席提出的2030碳达峰、2060碳中和的这个双碳目标。因此呢，水泥行业需要进一步看长远一点，进一步如何实现不光是降低空气污染物，还应该考虑如何降低我们这个二氧化碳的排放。因此呢，在我们的报告当中，我们也给出了一系列的水泥行业如何实现零排放的这样的技术和措施。在这里呢，因为时间的关系，我就不一一的展开了。但是呢，我们主要是把这些技术和措施分成4大类，包括提高材料的效率、提高能源的能效、采用电气化以及进行燃料替代和碳捕集。因此呢，我们建议呢，就是从水泥行业来说，我们“十三五”做得很好了。但是在“十四五”以及在未来“十五五”，我们为了实现未来的这个双碳目标，我们应该考虑一系列的措施，来不仅降低我们主要空气污染物的排放，还应该继续努力实现我们这个零排放。我的报告就到此结束。Jennifer, that's all for my talk, and I'm coming back to you.
Thank you so much, Hongyu. Just by way of introduction, Hongyu Liu is a scientific engineering associate with the China Energy Group at Lawrence Berkeley National Lab. Her research and analysis focuses on industrial sector decarbonization through thermal energy modeling, technology assessment, and data analysis. She has also conducted analyses on the technical and economic potential of industrial waste heat in the cement, steel, and glass sectors. So thank you very much for that overview of the cement sector, Hongyu.
Thank you.
And now we're going to turn it over to audience questions. So I'd like to remind everyone that if you have a question, you are welcome to type it in the Q&A panel at the bottom of your screen. There's a little tab there and you can type it in like a chat message. And while we're waiting for some questions to roll in, I might start off with a question for each of our panelists, which is to say, what were some of the most surprising or interesting or novel aspects that you found in this research? What was something that surprised you or maybe caught you off guard? Perhaps we'll start with Bob.
Well, I think the thing that was really apparent to me was that, energy efficiency has been around since the 70s, particularly for buildings. I mean, now first California building standards were in 75, appliance standards in 78. But having said that, there's still a very important tool to deal with in terms of greenhouse gas emissions and air quality. Having said that, they really have to be rethought and restructured some so that we're dealing with saving energy at times when there's the greatest greenhouse gas emissions, and not targeting much of our effort towards periods where, as I said, where we have surplus renewables. So, lots of opportunity there, but lots of challenges, particularly on the technology side.
How about you, Nina?
Sure, thanks, Jen, for the question. I think I was also very surprised, kind of looking at this from the dual angle of both energy efficiency, decarbonization, as well as air quality, since I think historically a lot of our work has been focused on either one or the other. So it was really interesting to see how policies adopted focus on air pollutant emissions, for example, could impact energy efficiency and CO2 emissions and vice versa. So, for example, when I introduced the results on the air pollution reduction potential for energy efficiency and new energy vehicles, we could see that there's really a wide range in the savings potential. And this is really kind of as a result of underlying the status of what's happening in China with its vehicle emission standards for heavy duty trucks. So China has actually begun to introduce one of the more stringent vehicle emission standards in terms of air pollution emission standards in the world. And I think, if that can be successfully implemented and enforced, then that will really help drive down the air pollution from these heavy duty trucks. But in the meanwhile, I think, as the trucking sector is still undergoing its market transformation, and there's still a lot of these older diesel trucks that are running around in China, I think that's where energy efficiency and some of these switching to new energy vehicles can really play a big part in reducing air pollution. So it's really interesting to see kind of these different policy mechanisms come together in terms of the impacts they can have on, the different criteria that we were looking at in terms of environmental gains and co-benefits.
Yeah, really good point. Hongyu, over to you.
Yeah, I think I was struck by the comparison that I made at the very beginning of my section, comparing the end of pipe and the energy efficient technologies. And I was just struck by the synergy actually between both of them, and also the trade-offs between them. It's not to say that one is better than the other. It's to say, in some cases we need both, but in some cases maybe one is better than the other. And it really needs kind of a systems approach to this question of how could we to improve our air quality, reduce our greenhouse gas emissions using the most optimal way, right? Reduce our costs as well. So we gotta have a optimized mindset coming into this, and a system approach, instead of, let's just reduce air quality, air pollution, or let's just reduce carbon. But we really do need to kind of put all of them into this framework. So that's my first takeaway. And the second takeaway, and I'll stop right there, is what Bob said earlier, the energy efficiency 2.0 going on in California. And I like to stress that for the cement industry as well. I think cement industry in China has done significantly improvement over the last 5-10 years. But I like to stress that, there's degradation of energy savings over time. So we gotta keep up with the good work in the next 5 years. So just another point on energy efficiency.
Great, thank you so much to each of you. Perhaps a question for Bob. So you have a long history of career in energy and climate policy and in the California context, and have drawn many lessons learned from that into this report. I'm curious to your thoughts about any challenges or barriers you might see to transferability to another region of the globe, and any challenges that you might foresee in applying some of the lessons learned and best practices that are recommended in the report, in a Chinese context. Any kind of barriers or challenges you might foresee with that, and how they might be overcome.
Well, certainly, the thing that's the message on, particularly say air quality as the example, you know, you're it's things are not necessarily directly transferable. The inventory of where the emissions are coming from, actually both greenhouse gas and air quality are different. And at the same time, as the emissions, again, we're 52% transportation. China is probably much more coal dependent generally for electricity, space conditioning industry. So again, well, we have little coal here. So again, it's not necessarily directly transferable, but I think part of where I see the connections are that, our strategy is very much to electrify things. And also, obviously, renewables are really now the lowest cost option to add more and more renewables. So as I said, we're at 38, or depending on your definition, whether you include large hydro, 50 some percent. Then as China goes from its current mix to having more and more renewables, then it really would need things similar to what California is looking at in terms of storage and flexible demand as a way to keep up reliability. But again, does China need that now? But the basic message, I think all the pathway studies I've looked at have basically focused on electrifying the grid or moving to renewables on the grid, adding storage, but moving away from coal and fossil fuels in general. And at the same time, then really electrifying all, transportation and just about everything you could imagine going forward to get to zero net carbon. So in some areas we're further along than China, but I think China will be able to benefit from our experience on dealing with these various questions. And as we go through and say stub our toe on how do we maintain a reliable grid, well, again, as China gets to the 50-some% renewables or 38, very high levels of wind and solar, it can get in place the basically storage for demand response or load flexibility prior to that stage. So, again, it's not going to be exactly the same, but I think the basic message on you have to clean up the grid, and as you have the grid cleaned up, then you can really electrify a lot of your opportunities and basically shift off of fossil fuels to renewables that for everything. That as you do that, issues emerge, and certainly they will be different issues in China, but they can at least learn from our mistakes. And at the same time, looking at the lessons that emerge here, saying, yeah, we need a much better heat pump technology. We need lower cost. We need to be really, consistent with the Montreal Protocol. I mean, that's a real opportunity. Just as China had a real opportunity in photovoltaics and LEDs and zero emission vehicles and now storage. Again, it's pretty clear that flexible appliances, heat pumps, I mean, there's just a lot of opportunities where we can combine the innovation needs with scale and innovation to really drive down costs and really make the transition easier into the technologies we're going to need for 2050.
Thanks so much for that helpful overview, Bob. We have a question about whether there are any quantitative findings or analysis in the report related to the synergies between air quality and pollutant reduction and carbon reduction. I think the short answer is yes, but yeah. If any of you would like to comment further.
Well, in the scoping plan, what the ARB does is it assumes that the percentage reduction in greenhouse gas emissions is equal to the percentage reduction in criteria pollutants. That's a relatively simplistic approach. And I assume particularly this next time through, they're going to continue to adapt that or, do additional modeling. I think the South Coast really dug much more into if you could reduce emissions, if you could have more energy efficient buildings, this is how it translates directly in terms of reduced criteria pollutants. And I think everyone again, on the mobile, I think for transportation, again, it's a lot easier to say if you move away from internal combustion to zero emission vehicles, let's quantify exactly what the benefits are in terms of greenhouse gas emissions and criteria pollutants.
Great. We have another question about whether there are any examples of Chinese companies' engagement in the ZEV or ZEV infrastructure business in California.
Well, certainly, like I said, in California, so first of all, we're about half of the US is zero emission vehicles. And I'd have to say Tesla is a dominant player in that area, although certainly it's going to get a lot of competition fast at this point from GM. Certainly at this stage in California, there's just an amazing variety now of zero emission vehicles offered, just not by Tesla, but by every other manufacturer. And the question ultimately over time is who's going to win the longer term race. But certainly Tesla has a head start. In terms of the charging infrastructure, I mean, the Energy Commission has really helped a lot of those companies to get off the ground. Although frankly, there's not a lot of money to be made in charging infrastructure at this stage. I mean, we were seeing that as you're not going to sell cars unless you had the recharging or fueling infrastructure in place for people. So it's much more of a state activity. Certainly the utilities have been very heavily engaged, but as you look at, say, a charge point or something like that, you're sort of guessing how many vehicles are going in and where people are going to be charging. So it's a more difficult business. It may get easier over time. But again, it's hard to, I would tend to say that and China obviously has a lot of charging infrastructure too in place at this stage. Again, it's a lot of that has been more utility or state financed. Certainly some companies are trying to get off the ground. And it's going to be a whole new business as you start looking at the much larger charging requirements for heavy duty vehicles. And again, it may well be as you get into that, for example, on the South Coast, that every major warehouse or warehouse district is going to have, what is a huge capacity substation, charging infrastructure in place for the trucks. But again, a lot of flexible load opportunities. So again, I think this is an example where the needs are pretty clear, but given, again, the difference is obviously the Chinese have been just phenomenal in going out and building infrastructure as more of a government activity, while the US has been more laggard there. So again, I could easily see China saying, okay, here's what we're going to do on, say, trucks or on automobiles, and just going out and building. While we have this combination of trying to see how much the market can provide with different activities and how much people can guess where to put things. But it's sort of a comparison, in terms of high-speed rail or trains in general. Again, for China, it's been much more just go out and build the infrastructure. And here we've had a combination of state and private roles, which in some respects has not shown as much results.
Okay, thanks so much. So unfortunately, we have run out of time, so we're going to have to wrap up for this evening, but would love to thank everyone for taking the time to join us. As mentioned, the newly published research is now available on our website. This event was being recorded, and the video recording will be available on our website as well in the coming days. And thank you all for joining us.